What does it mean to engineer clarity from complexity, to see beneath the noise and find patterns that reveal order, even beauty inside a chemical process? For 3 decades, Mr. David Lovett has shaped the world of advanced process control. From the humming cores of nuclear power plants to the hands-on challenge of commissioning new systems across continents, Mr. Lovett thrived in complexity. Bootstrapping Perceptive Engineering in 2003, he wove theory into practice, building a company respected for its precision, flexibility, and reliability. 17 years later, he passed the torch to Applied Materials and chose to give back, sharing his hard-won knowledge with startups and fostering a global community for scientists and engineers through the Royal Academy of Engineers and the Center for Process, Analytical and Control Technology. So welcome, David, to the podcast series, and thanks a lot for joining us.
Thanks, Lennon.
So firstly, maybe if you don't mind sharing a bit of your story, like how you got into from nuclear engineering to actually advanced process control systems.
Okay.
Yeah.
Well, I started in nuclear as straight out of university doing electronic engineering degree. And I went into, it was a graduate program. I didn't really know quite what I was going into. It wasn't exactly control engineering at the time. It was nuclear engineering, but I moved around a few departments, and the one that attracted me most was the control engineering systems department. That then took me quite quickly into application work on site.
Okay.
And I jumped at that opportunity. And in there, I got to see things like the high integrity control systems, mainly safety related, but also the hierarchy I think you have in control. So you've got the safety system, you've got the distributed control system, and then you've got the optimization system. And the whole sort of ISA 95 hierarchy of control systems existed then back in the late 1980s. But I think most importantly, being able to see that safety element and the safety case that was, to me, the most critical layer that you should never move into thinking about process improvement before you've thought about safety. So
sure. Okay.
And how did that take me? Well, having spent 3 years doing a mixture of control systems involving the high safety stuff, I just got an opportunity to see a range of new technologies that were coming out in the early 90s. So model predictive control, fuzzy logic control, genetic algorithms, neural networks were kind of all hot buzzwords. They'd been around in some industries, but they certainly hadn't propagated to all industries. And I got an opportunity, there's a company who was leading the way in predictive control. And they were quite local to me. Again, just opportunistic professor who set up the company, and I applied for a job there, and that took me into a small company, model predictive control.
And then from there, you, eventually you started your own company, like so.
Yeah, there's always a journey. So I mean, it's almost 15 years of working hands-on in application work, working in that team to be an engineering manager. And then that company was acquired. I was engineering manager for another team, started building solutions, started getting more involved in quality systems, training. And then in 2003, I got the opportunity to launch a company. But it was based on things that I was seeing in that sector in model-based control that I felt to make model-based control stick. You needed to make sure the instrumentation and the signals that were coming into your control system, which was typically quite a large multivariate system, that they were reliable. And so part of the vision in perceptive engineering was to develop a statistical monitoring system that would monitor the controllers and the process together. Okay, so that was kind of the vision, if you like, what we had to make more complex control systems more robust.
So what inspired or gave you? I mean, I know it's a cliche, but everyone's always asking what gave you that leap of faith to start your own company when you could be enjoying having a less stressful job working in a company rather than starting your own.
I think it's quite a bit of it can be in the nature of the person, how risk averse you are or how comfortable you are in leading something and having a go at it. An opportunity and luck coming together I guess as part of you being dissatisfied with what you're doing at the current moment, either dissatisfied with where you are in a company maybe, or dissatisfied with what industry is doing or what capabilities you see an opportunity. As I said in that, I thought model-based controllers were great, but they were missing something. And then someone came to me, that was the opportunistic bit. They came to me and said, you know what, we're doing some multivariate statistics where we monitor controllers. We've got a bit of technology we've got in the university. Do you want to take that out? And it was just the right time for me. And then fortunately, I knew a number of people, like-minded, very good engineers. I saw them, we were all relatively young, and I asked them if they wanted to join me, which I think is very important in a small company. You're not doing it on your own, even one or two of you. You're kind of doing it 3, 4, 5 of you. And then you can drive each other. There's a sort of inbuilt peer pressure and motivation.
And actually, the starting team is really crucial to setting like the whole company culture. So any like lessons learned to, for people who want to start their own companies, how do you identify or how do you make sure, whether you can even make sure, but how do you know that the person you're hiring is right for the company?
Yeah, I mean, there's so many things, aren't there? People talk about how do you hire and how do you detect attitude and the different psychological tests you can go through. I think for me, I either knew some people, I had the advantage of knowing people, so I knew how they performed, I knew how they were motivated. But taking on new people, you were certainly looking for attitude. You're looking for people who really are passionate about what they do outside of work, and that they'll carry that through inside of work. You're also looking for a team that complements each other. You've got some rising stars, which I think there are books on multipliers and diminishers, and as a manager, you want to be a multiplier. There's intelligence in your people. Your task is to bring it out. If you're ever the brightest person in the room, you probably shouldn't be in that particular room. So I always wanted to be the least brightest person in the room, but get the most out of my people. Hard. No, he wasn't. He wasn't hard. Believe me, he wasn't. It was easier than you would imagine. No, I work with some good people. Yeah.
Okay, sure, yeah. And then also as a new company, you have to like actually start selling your business, your product or service in different parts of the world. How was it like to commission like systems in different places, different countries internationally?
Right. I think when you start a company, the difference between working in a company is that you've got a responsibility that your systems have got to work, they've got to have longevity, they form part of a system that you've got to support. So you're not just doing an ad hoc one proof of concept project. You've not least you've got the responsibility and accountability if you're running the company, but also the liability, which is there, and it sharpens your mind as to say, look, what we develop, we have to train people so we can develop and install robust solutions. We've got to be able to maintain them through a life cycle. We're working with multinational companies that we respect, and we want to develop and design control systems that are there for the life of whatever the life is of that process plant effectively. So I think that's kind of the thought process you go through when you're running your own company, as opposed to working within another company, within a large company. You're kind of protected in a way and sheltered by legal and HR and a much bigger environment around you.
That's true.
You don't see everything. Again, working internationally, one of the differences is language barriers. The challenges you have there are making sure that what you've sold or what your sales team have sold actually matches what you can do, and there hasn't been a misunderstanding. So making sure that you're all aligned, you're getting to site, you all understand what your objective is, and all of you are collaboratively designing a control system, because the control system requires so many parts: process domain knowledge, equipment, PAT, sensor knowledge, finances, production. The part that you're doing is the control system, and it touches all of these areas. So you're very much working as a team, and I think that is challenging when you are working internationally in foreign lands where there's a language barrier. So you have to kind of make sure you've got a champion who communicates in the appropriate language. That's how we kind of managed it.
Okay, or we can go into more on the overall, like, since you're talking about control systems, just how you actually like package the business case when you're presenting to the customers. So we're talking about finance and everything, so all of this has to fit in when you're eventually proposing to the customer.
And there's always an inflection, and at the moment you see artificial intelligence, machine learning being a massive inflection. It's going to deliver so much. The same could be applied in a much smaller way to things like model predictive control or advanced process control, going back some years. How is it going to transform this process? The key to anything is understanding the business case. There's one thing to solve a problem that might be annoying, but can it be monetized? Can it actually improve the performance, the financial performance, or the sustainability of the plant in terms of minimizing waste, reducing energy usage to achieve the same output and the same quality? And that's kind of what you're trying to do. What you have to do is very much benchmark how well your process is performing now. And again, the tips in there are so many tips. There's the whole methodology to go through on how to genuinely and honestly benchmark your process, not because you want to do the project. So you can find a champion who really wants to do the project, who may choose to show how a process plant ran on a particular bad day and it could be improved. Well, that's true. But a process plant can also have a really easy day. It can run very well. So what you're trying to achieve is consistency. You're trying to achieve the best possible performance, optimum performance all the time. Optimum performance when you've got a huge disturbance and a very poor quality raw material may not be the best performance you've ever achieved, but it's optimum given the conditions presented to you. So what I'm saying is when you do the business case, be honest about the analysis, benchmark average performance, benchmark best performance, and benchmark worst performance, and then look to see what you can achieve. Now, the challenge with that is it then often becomes a statistical metric. Now, we know things about statistics when you say, well, statistically, I should be able to operate up here and increase the throughput by 9%. And that's an extra 2 million a year to you. But what happens on a bad week? And anecdotally, someone will go, well, we put the system on, and on a bad week, it didn't perform very well. It's understanding the fact did it do all the right, did the control system you designed do all the right things, given the bad circumstances that it was presented with? So what I'm getting at in a long-winded way is that benchmark allows you to go, under really bad conditions, which are these, it will perform like this. Under average conditions, it will perform like this. Under great conditions, it will perform like this. So you get a full benchmark. And then you get expectations and reality are much, much closer. Rather than just say, we benchmark our plant, it performs like this, and you pick the worst possible run you could. And then when you put any control system on, it's probably going to perform better. It's been having integrity and honesty and methodology in your benchmarking that's important, because that gives you a true baseline that you can calculate your return on investment on.
So besides obviously like painting a very clear picture of the ROI to the customer, what do you think is also needed in the proposal, or what are the common kind of pushback you receive when talking to customers, and how do you overcome that?
Yeah, I mean, in the sort of selling new tech, there's some great books around on this, technology patterns. It's selling new technology to anyone. There's ways of doing it. I think from my experience in control systems are really hidden. They're part of a system and they're hidden, and no one really wants to talk about the mathematics or the stability or the dynamic performance particularly. It's not that interesting to most people, but it's what enables you to perform as it does. It's what enables process plants to operate as they do at high performance levels, consistently, reliably, even when you've got lots of disturbances and changes in raw materials. I think the points you're making about selling is it's usually you're trying to emphasize that what you're doing is not particularly risky. So you're de-risking something. Most people perceive any new technology as relatively high risk or no. So you've got to de-risk it with references, de-risk it with a balance with, well, these are the benefits you're going to get against the risk. So you can be good at making that business case. You've also got to work as a system. So know that whatever you're doing is part of a system, and everyone has to understand what part they've got to play. So if you know how well your new instrument or your new control system is going to perform and enable the process to change to a new operating point, operations staff need to know that clearly. It might be operating at an optimum point, but it might be closer to the specification limits perceived as risky. We don't often run there because if we ever exceed that, we're outside specification, we waste product. So everyone has to be, from production to quality, to finance, to your automation team, to your IT team. It is completely a systems approach you need to take, and you need to share that. Now, that requires you go into a whole decision-making unit when you're selling. So selling a complex solution is quite complex in itself. You're selling to a decision-making unit of which you should, and that decision-making unit should be all those people I've just listed. To ensure that everyone buys into it and doesn't try to, when something goes wrong in their area, they don't try to find an excuse.
Yeah. So everyone's aligned.
Everyone's aligned. They understand the assumptions. They understand what you're doing. And then you'll start to see success.
And did your biggest success came from when you got clear alignment with all the stakeholders, or did it come unexpectedly from some relation that you had somewhere, some friend or work professional contact you've made over the years that gave that huge deal or something? So
yeah, it's both. I don't think there was, I can say there's any particular big deal that's come from knowing someone for years who's then, trusts you. That does happen if you do good work, you win work originally, you do good work, people want to buy from people who are succeeding. But that's just part of life. I think some of the biggest wins come quite surprisingly. You might be given the best opportunities when you see a process plant that's really performing badly because its control system is really bad. So then there's a lot of low hanging fruit. You go in there and you do the base layer. You improve the regulatory control, and that's critical. You also ensure that the instrumentation is reliable, also critical. So you're building up this structured approach to going, well, I make an improvement because I've got better measurement. I make an improvement because I've got better regulatory control. And then I've got an improvement. The top layer that we were used to dealing with was the optimization or the slightly more complex multivariable control. You got benefit from that as well. So those biggest wins could be huge. There could be millions, in terms of throughput, or in terms of minimizing energy usage, or in terms of having less out of spec product that went to waste or reprocessed. I don't know if I answered your question there in that many things are sold based, you do a proof of concept, you succeed, and you sell a few more of them. Sometimes you get opportunities with people who've worked with you before in another industry, and they go, you know what, these guys have done something great, pulp and paper. Why can't we use them in bioprocessing?
Yeah.
So that can happen, and you get sometimes a nice opening there.
Yeah.